Hello and welcome everyone. We are officially live and it's wonderful to see so many of you joining us today. You made a fantastic choice to invest your time here because this session could be a real game changer for your academic and professional journey. I'm Chetna Kapoor from Seed Global Education. We are a UK headquartered company that facilitates connections between leading global universities and students like yourselves. Our mission is to help aspiring students explore programs, connect with faculty and admission teams, and make informed decisions about their higher education and career goals. To get us started, could everyone quickly drop in the chat which city or country you're joining us from today? It'll give us an idea where you're joining and how this masterclass is going to shape you. Um, Welcome to today's masterclass hosted by the University of Maryland's Robert H. Smith School of Business. And we can see that people are joining in from New Delhi in India. Uh, there are people from Assam. I'm just waiting for people to join in. I have over 150 people already who have joined in. Yes, a lot of people from Delhi, Mumbai, Patna, like all the lengths and breadths of India for sure. All right. The Smith School is a globally recognized institution located near Washington, D.C., known for its cutting edge research, diverse faculty, and strong industry connections. With a focus on data driven decision making, entrepreneurship, social responsibility, and experiential learning, Smith equips students with the tools, insights, and ethics to excel in their careers and make a positive impact in business and society. Today's session introduces the fundamentals of data mining and predictive analytics, how businesses apply these tools to understand patterns, forecast outcomes, and make smarter decisions. We'll also explore how data influences strategies, shapes success, and drives competitive advantage in today's world. This is also your chance to learn about scholarships, funding opportunities, and the application process at Smith School, and to directly interact with experts who can guide you in your study abroad journey. Let me quickly introduce all of you to today's speakers. First, we have Dr. Prasad, Research Professor and Academic Director at the Center of Global Business. His expertise spans data analytics, machine learning, and economics, and his thought leadership has been featured in publications such as Fortune and US News and World Report. At Smith, he teaches across MBA, EMBA, and PhD programs, helping students apply those insights to solve global business challenges. Welcome, Dr. Prasad. Alongside him, we are pleased to welcome Kelsey Coleman, Program Manager at Smith School, where she oversees recruitment and program management for the Business Masters programs. Kelsey has extensive experience supporting international students through the admission process and guiding them in making the most of their academic journey at Smith. So before we begin, let's make this a little bit interactive. I will launch my first poll question on your screen. Everybody, just take a few seconds to respond, and we'll see where everyone stands. And here it is. Uh, Second. Yes, what part of the data journey do you find most exciting? I will give you a few seconds. Is it collecting and cleaning data, finding patterns in data, predicting future outcomes, or using insights to make decisions? This will also give Dr. Prasad an idea of how his presentation is going to go. Um, I will let this be on your screen for another 2-3 seconds. I'm waiting for more responses to come in, so yes. All right, ending the poll now, and the results are here. So, maximum people feel that predicting future outcomes and finding patterns in data is the most exciting journey of this. So, I'm handing over the presentation to Dr. Prasad, and I'm excited to listen to you.
So, yeah, it's a pleasure to join you here. Welcome, everybody. So, I think that poll's really interesting because collecting and cleaning data, if you ever get a job as a data scientist, that's what you'll spend 90% of your time doing. But I agree that all of the others predicting future events and all of those are actually the more exciting part. But unfortunately, just working with and cleaning data is what you spend most of your time on. Okay, I'll actually tell you one little fact about the University of Maryland that you might not already know. And that is Sergey Brin, one of the co-founders of Google, was an undergraduate student here. So he's one of our most distinguished alums in the the data analytics kind of field. Okay, so what I'm going to talk to you about today, and let me start sharing my slides. So is a class that we teach in all of our master's programs in slightly different versions. So in all of our MS programs, and I think I've taught it in each one of those programs, and currently I teach it in our full-time MBA program. So it's data mining and predictive analytics, and of course it deals exactly with what the poll questions were about. So it's a class in which you go through each one of those steps that's mentioned there. So, I didn't want to make this talk very technical. What I want to do is just give the kind of overview I give in the first lecture of this class to students, particularly in MBA classes where people might come from multiple backgrounds, of what this subject or what this course is about. And let me do that for you very quickly. So first, yeah, there are two things that we call it data mining and predictive analytics, but it could also have had names that included within it data science and business analytics. So it's really a course at the intersection of business applications and the core data science methodology. So I'll start by just giving you a quick introduction to what these two are. So data science first, it didn't exist as a field 20 years ago, and it's one of the fastest growing in current times. In the last 5, 7, 10 years, it's been particularly seen explosive growth. So it's the field of study devoted to collection, storage, preparation, analysis, presentation of data. But it's always good to keep in mind what the goals of the subject are. And the goal is, especially when we teach it in the business school, how do you extract useful knowledge and guide managerial decision making? Right? In some sense, what we want to do is get business value out of data. And so that requires a command of lots of different things. So you might ask, well, what is the skill set of a data scientist? Another way of putting it might be, well, what is it that I can expect to learn if you come to our program? So I think the skill set includes a few things. First of all, it includes the scientific method. We have science in the title of the job category or subject itself. So science has developed a systematic method of getting knowledge out of pieces of information. So we apply the scientific method. You need to know a reasonable amount of mathematics and statistics, particularly statistics, but a little bit of you have to have some kind of a quantitative outlook, and you learn some of that. And then, of course, you need to program and understand modern digital technology. So there's some of that. But what I really want to emphasize here is that you also want to understand how businesses work and function. So business domain expertise, because you wouldn't be able to be effective if all you had was the technical skills, but you didn't understand the business domain expertise. And that's why, we have lots of employers and others come to us because they want people at that interface of business and data science. I think this quote by Hal Varian, who was chief economist at Google, UC Berkeley professor, sums it best. He says, the ability to take data, to be able to understand it, process it, extract value from it, to visualize it, communicate it, that's going to be a hugely important skill for the next decades. And I think these are all guiding principles for the course and also to many of our programs of what is it that we want our students to be able to do Well, that quote, in some sense, sums it up. So, quickly, what is business analytics? So it's you can think of it as the science of making better decisions. So what really guides this is how do you use data to make better decisions? You can do it by statistical methods so that your decisions are based in fact and evidence, they're data driven, they're evidence based. But also, we use a lot of optimization and mathematical models so that you make optimal decisions and you understand constraints well. Right, so that's in some sense a traditional definition, but I think in modern times we have elaborated upon it. And historically, all of this started as application of statistics to business problems. A classic one being quality control, and this was even in the 1900s. Statisticians were doing quality control, and there's a famous example of Guinness Brewery where the tea test was invented early 1900s. So a lot of time, and historically, people have always wanted to predict demand and sales and those kinds of things. So we've always been doing statistics, but the field has grown to include business solutions using machine learning and the business of creating data products. And by data products, what do I mean? Products like LinkedIn that exist entirely in the digital space and make full and complete use of data. But the broad goal hasn't changed. I mean, it's always the focus is going to be on how do you create and extract business value from data, and that's I'll give you some examples of that. It would be remiss if I didn't tell you where we are today, and I think we've always been doing forecasting, but there was a quantum leap in the science of prediction. That happened with what we call predictive analytics, lots of algorithms that were, that allowed us to predict better. Deep learning was a big thing starting around 2004. It became big, and then it got pioneered by the big tech firms. So that's where we are today. And today's frontier is artificial intelligence. But artificial intelligence is basically all about prediction. It's and I think I'll give you a quick example of, say, self-driving cars. I'm old enough to remember, going to the Carnegie Mellon campus in the 1990s to see one of the first self-driving cars. And they were basically rule-based. There were a lot of if-then statements, basically telling the car how to drive. And I saw it on one, it would look like a 400 meters running track, and the car could hardly stay on that. It would keep going off. Today we have really good self-driving cars. But the algorithms are very different, right? So how is it about prediction? The algorithms at all times are built to predict what an expert human driver will do. So, and then they are trained with expert human drivers, and at all times the algorithm is predicting what the driver will do next. If the driver does that, it reinforces that behavior. If the driver does something else, it readjusts parameters to better match what the driver did. So basically, the algorithm goes through hundreds of thousands of miles of training in this sense, so that it can learn how to drive. So again, as I mentioned, it's basically the science of prediction getting us self-driving automobiles and lots of things. If you look at hottest new startups in artificial intelligence, dig deep enough, ultimately they've seen some problem and turned it into a prediction problem. So predictive analytics is at the heart of artificial intelligence as well. Okay, so one of the things I wanted to give you was some major use cases and applications in business. And these are all, it'll be a small list, but each of these is hundreds of billions of dollars have been created using these methods. The most basic and the most widespread is the idea of predicting preference. The point is, who's going to buy what? Right? So preferences, what do people like? So who's going to buy what? Predicting that is at the heart of much of what these predictive analytics methods do. One example is recommender systems. If you go to Amazon or Netflix, it's trying to predict what are the books you will buy, what are the gadgets you'll buy, what are the movies or shows that you'll want to see. And it's customizing its prediction to the individual and making recommendations. So recommender systems is one example of this kind of an algorithm. LinkedIn identifying people you may know. Again, a major business application. LinkedIn, of course, now is owned by Microsoft, but his founder said, the building the people you may know feature was the most important thing that we ever did. Predicting who will click on an ad, right? Google has become one of the most valuable companies in the world by being very good at predicting who will click on an ad, and therefore being able to target ads better. And then, of course, they make much of their money from advertising revenue. Presentation of information in news feeds. What will people want to read? What will people want to watch? All of those kinds of things. Facebook, but lots of other people as well, have made a fortune doing that. Then customer churn, identifying customers who are at risk of ceasing subscription. Right, so that's, for instance, you might have a telecom company, here in the United States, Verizon is one of them. And so there's a lot of customer churn. People go from one service, Verizon, to T-Mobile, to something else. And so it's important to identify who's about to cease their subscription and go someplace else, because you can offer them a good deal to stay on, or you can proactively reach out to them. You can do something to try and prevent that from happening, because acquiring each customer is really, really expensive. Right, so that's, and I think that may be, I have one more, which is, it's a kind of project I've worked on myself, which is fraud detection. Right, so people submit claims to be reimbursed for medical expenses. But it's unfortunately, people might submit fraudulent claims. All right, they didn't actually get the medical service, but they've created a claim that looks genuine, and they submit it in the hopes that it'll get paid. So how do you tell a fraudulent claim from a genuine claim? Right? And so that's another kind of a prediction problem. So you're trying to predict based on everything that is submitted in the claim and possibly some auxiliary information, whether the claim is fraudulent or whether it is legitimate. Okay, so here I'm just giving you some examples of the kinds of recommender systems you might see, recommendations in books, and those are customized. I'm sure I see this introduction to econometrics and causality and statistics and so on. I suspect you see different books suggested to you. And then again, suggestions of shows to watch and so on. Recommender systems, of course, are for all kinds of things, as I said, books, movies, romantic partners, all of these are different examples. With a view to time, maybe I won't get into too much into the details of this, but I'll just give you just a simple example to give you a kind of view. So you have say 5 shows, and you have in this my example there are 4 individuals: blue, red, yellow, and green. And nobody's seen all the movies, but they've seen some and expressed happiness at seeing some, and unhappiness at seeing others. So here's blue, has seen 3 shows and was happy with 2 and unhappy with 1. Here's red, happy with 2, unhappy with 1, and so on. So you've got for everybody. But the main thing is, your question might be, should I recommend Daredevil to red? So in this case, let's say this is all the information that you have. Well, one thing you can say is, let's look at all the people who've seen the movies that red has, And so in this case, there are the second and third shows. And well, there's blue here who's seen the same, and their tastes seem to match completely. So a reasonable thing to do would be to suggest that, well, possibly since their tastes match on everything where they have a common intersection of viewed shows, maybe I can predict that they would be unhappy with this because blue was unhappy with this. Right, so it's a bit like saying, I have to go to a movie and I don't know whether to see it or not. I'll say, oh yes, I have this friend and we tend to like the same movies and they've seen it. So I'll go to them and I'll ask them, did you like this movie or not? And then I'll be guided by that. Another thing, of course, you could do is say, well, here's a show. You're looking for what to recommend for yellow. Here's a show. Everybody seems to like this. So, I might as well recommend that because it's basically a very popular show in my database and so on. So, that's just simple. It's much more complicated than that, but that's just a simple elaboration of two particular ideas that you might use to, to try and predict preferences here. Another very simple example, fraud detection in credit cards. So a credit card company keeps track of two features. So distance of charge location from billing address, transaction amount. Right? And so our problem here is, can you identify fraudulent charges? Right? And so I'll discuss two cases. One is you have a historical database which identifies both fraudulent and non-fraudulent transactions, and one where you only have data that you've certified to be non-fraudulent. Right, so again, we have only two features. So we have, we can represent one on the x-axis, one on the y-axis. So that means each point is some combination of size and distance. And then I'm going to use labels to identify whether the transaction was fraudulent or not fraudulent. So the red circles are fraudulent transactions and the green crosses are non-fraudulent. Now you've got suddenly, so this is your database. Now suddenly somebody's making a new charge. And in this case, you have to determine, is it fraudulent or not? And one logic you might apply is that, well, everything in this region tends to be non-fraudulent. So I'll predict it's non-fraudulent. Right? Similarly, you have another one. Is this fraudulent? This is a region of a lot of fraudulent charges. So maybe I'll flag this to be followed up upon. And then, of course, you might have ambiguous cases as well. So the idea of what is close by is formalized in an algorithm. Some of you may be familiar with it, called k-nearest neighbor. So the k-nearest neighbor tries to label things based on what nearby transactions in the feature space, what labels they have. So they could say, I'm going to find the three closest and take a majority vote and so on. So that's an approach you might take. You might also, what you can do depends on the kind of data you have. So it's supposing all you have is non-fraudulent transactions, verified non-fraudulent transactions. Well, here what you can do is build a probability model. You can build a range around it and say that, yeah, if anything comes in this range, I'm going to say that's fine. If anything is way outside of this range where I know all of these good transactions to be, then maybe I'm going to flag it to be followed up upon. Nowadays, you might get a text on your phone saying, I see this transaction being made. Can you verify that it's you? That kind of a thing. Okay, so so anomaly detection basically formalizes this intuition. Okay, so in case you're interested in a definition, what is machine learning? So a lot of ML algorithms search for patterns, right? And so what you're doing is looking for patterns. And you can think of machine learning as computer systems or algorithms that use data to automatically improve at some task or the other. And then the key part is that they have to have the ability to generalize to new settings, right? So we say learning has genuinely happened if based on past data, you can build a system that has a very good level of performance with new data. Right? And so I'll give you one example. Let me skip unsupervised. I'm just a little short on time. So I'll stay with supervised learning. Right, so you've got, here's your database on which you train your algorithm. So this is what we call label data. So we have lots of images of things that are dogs, of mammals that are dogs and mammals that are not dogs. And so they're labeled, and you're teaching an algorithm to distinguish between a dog and something that's not a dog. So, it goes through all of this. The algorithm processes all of this. We'll say learning is good if it becomes good at identifying images it has not seen before. Right? That's what I mean by generalizing to new situations. So it's not information retrieval. I can't show it same images that it was trained on. I have to show it something new. That's when it's actually figured out aspects or patterns of one mammal that distinguishes, of dogs that distinguish it from other kinds of mammals. So yeah, we'd give it new data and want it to be able to tell that, yeah, the first image is that of a dog and the second image is not of a dog. So that's supervised learning because we're basically showing it lots of images, saying this is a dog, this is not a dog, and teaching it to distinguish between the two. Okay, so maybe how much time do I have? Well, now let me plan my rest of my time based on that.
You do have another 5 to 7 minutes, yes.
Okay, 5 to 7. That's good. Okay, so then so what I'll do now is basically show you, the kind of methodology, right? So what I described to you is we want to train an algorithm to be able to generalize when it sees new data to have a good level of performance. And so the basic methodology that we have is you build models to minimize out of sample prediction error. So what happens when you see new things? You want it to be good there. And so the methodology that we use is we take data and we partition it. And we call one piece training data and the other maybe sometimes test data. Sometimes we have 3 data sets. There's a validation data set as well. And so what you're trying to do is build a model, a predictive model that minimizes its errors out of sample. So in this case, I've got a simple example of a company, multiple quarters, time is on one axis, and its company's revenues are on the other axis. So I might have all of this data, but I'm trying to build a model. What I do is I'm going to use only these blue dots to build my model. And in this example, what I'll do is I want to fit a curve to this, which describes revenue as a function of time. And so let's, a big problem that often arises, and that's what, we are often trying to avoid, is that if I was to use all of the data, I would have this problem of overfitting. That it's very common to have a problem where you're really good at explaining the data at hand, but your model doesn't predict well, right? So what we want to do is avoid that, and that's why we are using this partitioning methodology. So we'll build a model here, predict here, and I'll illustrate how this overfitting problem arises and how we try and avoid it. So we don't have new data, but we keep some future data out. So here what I do is, I take these blue dots and I say, I'm going to find the best straight line that fits these. Yeah, the method algorithm is called linear regression. Some of you may be familiar with it. And there's something called an R-square, which tells you how closely you fit all of this observation, all of this data. So I might say I'll fit a straight line, and and I find some measure of fit. Then I say I can take a more complex curve. I can make my model more complex, and I'll fit a quadratic model. And so here I see, I have more flexibility with a quadratic model. It can be straight, but it can also have some kinds of curvature. And I find that, yeah, it fits my data at hand better. Then I said, well, why not do more of a good thing? What I'll do is I'll fit a cubic model which has more parameters, so it gives me a greater degree of flexibility, and that's the cubic curve that I fitted to this data. And that actually fits the data even better, the data at hand. And then I'll stop at the fourth order polynomial, the quartic model, and this fits even better. Right? And part of, is we're adding more parameters to explain the data because this has more and more terms, this equation. So we're, obviously going to be able to fit the data better. But now look at the orange dots. When you look at it, is your best model going to be the one that fits the data at hand better? Or is it going to be one of the simpler models? And quite obviously, we can see, and I think I'll show you the predictions. So the orange dots are there, but the lines are the predictions. So you have the linear and quadratic actually do fairly well, both of them. I think the quadratic is the best, I believe. I don't have those metrics written here. But the cubic is really bad, and the quartic was so bad that my whole axes would have become distorted if I included that. So the basic point here is that your best predictive models, when your criterion is out of sample, needn't be performance metrics of how the algorithm does in sample. Okay, so this is the basic methodology that all machine learning supervised machine learning algorithms use, and that's what we do in my course, in this course, with the multiple kinds of algorithms that we learn here. So this data partitioning methodology is what we do is each time we compute the error out of sample, like I've done here, how far I am from these orange dots in out of sample prediction. And that's called my test error, and I pick the model that minimizes my test error. So that's how we avoid this overfitting problem, and that's basically an important part of the methodology here. Okay, so yeah, I have another example, but I think I've made my major points. So quick recount of the three things. So first thing I talked about, how organizations turn data into powerful insights. So we went through major use cases such as predicting preferences, predicting fraud, determining who's going to click on an ad, those kinds of things. So we built predictive models to do that. You saw what the predictive analytics methodology is and saw the key stages used in getting actionable knowledge from your data. I will stop here and stop my screen share. So.
Thank you, Dr. Prasad, for breaking down so nicely, and those examples were really engaging. And I hope people get the how data analytics can guide smarter decisions in business. Before Kelsey shares more about Smith's graduate programs, scholarships, and opportunities for international students, let's run our second poll question so that we get an idea. Just a second. Okay, sorry. Yes, here it is. This is the second poll question on your screen. I would request everybody to take a few seconds to answer what kind of support would be most helpful for your study abroad plans. And let's set the tone for the next presentation, right? So that we have an idea. Is it guidance on applications, information about financial aid, advice on choosing the right program, or tips for overcoming challenges abroad? I will leave it on your screen for a few more seconds. All right, ending the poll now. I think the highest, it's a very close call between information about financial aid and advice on choosing the right program with just 1% of difference. All right. And with that, I will now hand it over to you, Kelsey.
Awesome. Thank you so much. An awesome presentation, Dr. Prasad. That was awesome. I do want to kind of piggyback just a little bit, not on Dr. Prasad's presentation, but just discussing more about the programs that we offer here at Smith. And then I'll also go over the application process and a financial scholarship opportunity as well that we offer here at Smith. So I do have a presentation prepared for you all today that I will share. And everyone is able to see my screen, right? Okay, so let me do this. All right, so again, just to reintroduce myself, my name is Kelsey Coleman. I am a program manager for our MBA and MS programs here at the Smith School. Just to give you guys a bit of a background on the University of Maryland, we have been recently ranked a top 10, ranking at number 10, public university here in the United States. Some of our highlighted programs have been the Management Studies program, our Master of Finance program, and our Information Systems program. For those of you who are interested in artificial intelligence, it's pretty much integrated in all of our program curriculum, but there is a specific, more heavy focus on it within information systems, business analytics, and also within our finance program and marketing analytics. So pretty much our analytics and finance programs is where you'll see more of a heavy integration of those folks that have like a technical background, if that's your interest and you're looking to go into data analytics, predictive analytics, things of that nature, then those would be the programs that I recommend considering. And I'll get more into that throughout the rest of the presentation. But just so you guys see here, University of Maryland is a powerhouse in research. We are a huge research university, putting out a lot of different projects year after year. Some of our faculty highlights, we have two Nobel laureates as well. We have 75 members of our national academies. We have one Emmy Award winner, one Tony Award winner, and we have five Pulitzer Prize winners. We are a school that also have notable alumni that includes Sergey Brin, who is, as Dr. Prasad mentioned earlier, who is the Google co-founder. We have Dorj Danzig, who is in linear programming, Kevin Plank, who is the Under Armour founder, if you guys are familiar with Under Armour. And then we also have Carly Fiorina, who is the former CEO of Hewlett Packard. So we do have 8 business masters programs that we offer here that are all STEM eligible. We have the accounting program with finance and quant finance. We have our analytical programs, which are business analytics, information systems, and marketing analytics. And then we have 2 management programs, which are supply chain management and management studies. And then we also offer our full-time MBA program as well. That is not a business master's program, that's our MBA program. But these are the main programs that I'll be highlighting in my presentation. So I do want to also highlight our Center for Artificial Intelligence in Business department. This program, or excuse me, this center focuses pretty much in developing AI algorithms for business challenges with a focus on creating AI systems that are ethical and that are also within respect of, rules, laws, and operate within regulatory business boundaries. This center also leverages the expertise of faculty from across various disciplinaries. It collaborates with the university's broader artificial intelligence interdisciplinary and institute at Maryland, which is AIM, which you see here. Some of recent projects that this center has produced are AI chatbots to provide mental health care. So if you're ever like on let's say Psychology Today, and you see like a little chat box that's asking you guys like, hey, how can I help you today? How can I best service you? That's utilizing artificial intelligence, and we have researchers that have developed that for mental health care facilities. And then also AI job tracking as well, which a lot of companies are now utilizing when they're reviewing resumes, and reviewing candidates for positions as well. I know we've seen a lot of that. I don't know if you guys are on Instagram, or on TikTok. I've seen a lot of different ads where companies are utilizing AI bots as well to kind of pull out those top talents within different industries. So that's something that our researchers have also developed. So why consider the University of Maryland here at Smith? Smith integrates AI and machine learning within our curriculum. We also have an awesome career services department as well that assists students in finding post graduation job opportunities as well as internship opportunities. Last year, we had 89% of our students report that they found full-time jobs after graduating, and that was through going to career coaching. So we actually have seven career coaches that sit within Van Munching Hall, which is the Robert A. Smith School of Business, that work specifically with our graduate level students and assisting them in, again, finding those post-graduation and internship opportunities. They do resume building, interview prep. They also have now just recently launched if you need business wear attire, or if you need some advice on how you can show up and put your best foot forward when speaking with certain employers that they've built relationships with. They offer coaching in that aspect as well, and providing you resources and making sure that you have a decent blazer or a nice suit and tie for our gentlemen, or blouse for our ladies, whatever the case may be, making sure that you are professionally um, equipped and prepared when going into those interviews, and making sure that you have a full knowledge of the company before you step foot in those spaces. We have over 70,000 alumni as well, and we have awesome partnerships with prestigious companies. Just to name a few that are listed here, the U.S. Department of Defense, the National Institute for Standard Technology, Lockheed Martin, Capital One. And then we also have some on-campus centers and clubs, as I mentioned earlier, which is the Artificial Intelligence at Maryland. This is the group that partners with our Center for Business Intelligence, or excuse me, Artificial Intelligence that I mentioned earlier. And then we have our Master Student Club and Association. They plan a lot of events for our students. That if you guys want to travel off campus, or get involved more on campus, it's kind of like your student government association in a sense, but it's specifically with students led by students that are master students here at Smith. So some companies that have recently hired our Smith students include Capital One, ConResnick, EY hired a ton of our students this past spring. A lot of them traveled to New York because they found full-time roles there. KPMG, Accenture, TikTok, Apple, Amazon, Deloitte, Morgan Stanley, and this is literally just naming a few. One thing that our Office of Career Services does a very good job of is locating employers that want to work with and come to our career expos to speak more specifically to our Smith students, and kind of getting you guys in those doors. So I always tell students, when you arrive on campus, we are already preparing you over the summer before you even arrive, how you're going to stand in front of those employers, because we're already building those relationships for you guys on the back end. One of the key things that I always tell students is meet with your career coach every 2 weeks, so bi-weekly. A lot of job opportunities, especially if you're interested in internships over the summer, those applications open over the fall semester. So you're going to want to meet with your career coach on a more regular basis so that you're not missing those applications. You're more prepared for those interviews. You have any projects or anything that they feel like you should highlight going into those interviews, that's where your career coach will step in and provide you with those resources. So just going into the scholarships and going into the application deadline. So we offer merit-based scholarship awards. It's on a first come, first served basis. Our upcoming deadline for our applications is October 15th. The priority deadline for international applicants is going to be January 15th, and the final deadline for international applicants is going to be March 13th. I highly recommend getting your application in sooner than later, just because it does take around 3 to 5 weeks to process an application after it's been deemed complete. Scholarship ranges between $2,500 to $15,000. And again, it's based on a holistic overview of your application. So everything that is included in your application is what's considered in determining your scholarship amount. We're looking at your personal statements. We're looking at your resumes, your transcripts, making sure you met those prerequisite course requirements. And we're also looking at your GMAT, GRE test scores, excuse me, if it's required for your program. And that's pretty much it. If you want to learn more about our programs, I do have a QR code here for you all to scan. If you want to connect with one of our recruiters so you can learn more about your specific qualifications for our programs, you'll also be able to schedule a consultation on this link as well. You can also send us an email to smithmasters@umd.edu if you have a more personal question and you want a little bit more guidance on a specific scenario, or if you want us to review your transcripts to see if you've met the prerequisite course requirements. You may send it to us here at smithmasters@umd.edu, and we'll review it, and we typically get back to folks within 1 to 2 business days. All right, so that does conclude my section of today's presentation.
Thank you, Kelsey. That was insightful. I think many of our participants will walk away today not just with clarity on Smith's programs, but also with a sense of how much personalized support students receive here, from admissions to career outcomes and everything. So now let's open up the floor to questions while the the audience are still typing their questions in the box. Let me start with a few to get the ball rolling. Dr. Prasad, this one is for you. There is Pranjali Dam wants to ask, many companies struggle not with lack of data, but with too much data. What advice would you give future leaders on filtering signals from noise?
So great question. That's pretty much all that we, what this and multiple courses are about. That you've got data, and as you correctly pointed out, data has signal as well as noise. And how do you extract patterns and leave noise? And something as simple as averaging, if can cancel out the noise, but uh, but in some sense, the overfitting technology I was talking to you about, that is also a way of trying to filter out noise. Why is that? Because when you make a model very, very complex, what it starts doing is it has extra parameters, and it starts explaining noise. And that actually is at the heart of what that overfitting phenomenon, that I know I rushed through it, but is about. So what that data partitioning technology that I was telling you about, looking at out of sample prediction errors, that picks out things that are not so easily distracted by noise, let's say, and that are good at picking out patterns. Right? In my example, the quadratic was much better than the much more complex model, and that's because those complex models were more they were more susceptible to looking at noise and saying, hey, this is a pattern. So I guess what I'll say is that we have this well-established methodology which tries to get exactly at that how do you get the pattern out of the data, and you leave the noise behind. But yeah, great question.
Thank you. Thank you. I see Kelsey typing the question that I was just about to ask her next after this. Kelsey, can you please tell, many students wonder what's the difference between a good application and a truly memorable one. Could you share an example of what stands out in an applicant?
Yeah, absolutely. So I just typed out the answer, but I'll share it with you guys as well. What stands out for a, standout applicant is really in your essay and also your background. And, we're looking at your applications, you guys, holistically. So everything that you include in your application is considered. But one thing that I think really stands out is your essay. We don't have an interview process for our business master's programs. We do for our MBA. But for our business master's programs, your essay should only be 300 words. I wouldn't exceed that. But you're also going to want to highlight why you're choosing the program in which you're applying to. And you're going to also want to answer why Maryland Smith. And I recommend answering that from a career standpoint, just because we want to understand what are your goals? How is the information systems program going to help you in achieving your goals long term? Some students may say, like, hey, I need to do this program because I want to enhance my skills in cloud computing or emerging technologies. Those are two focus areas that are within the within the information systems program, as well as artificial intelligence and data science. So kind of doing a little bit more research and speaking with the recruiters about the program that you're interested in, making sure the program aligns with your goals 5 years from now, 10 years from now, whatever the case may be. How is it going to help you get to your next step? That's essentially what the admissions committee is looking at within your applications. But I think that's also very helpful for them to get an understanding of you yourself. There's no really right or wrong answer because, again, within business, folks are coming from various backgrounds. We just want to understand what your plan is and how we fit into you meeting your goals within your plan.
That's great. That's great. Dr. Prasad, the next question is for you. What are the most common mistakes businesses make when applying predictive analytics to decision making? And if you can share an example where predictive analytics has completely changed a company's strategy or an outcome.
Well, so the most common mistake is not recognizing that the future may not be the same as the past. So that's basically not generalizing. So uh, finding the right data and knowing the limitations of your model, I think, is the way I'd put it. That sometimes firms don't necessarily appreciate the limitations, and they think in terms of accuracy of the model or the error rate of the model, but they don't appreciate that different kinds of errors have different business costs. Not so that, for instance, false positives, false negatives, for those of you who understand that. But in the context of an example, the cost of telling somebody who's not submitted a fraudulent claim that, hey, you got a fraudulent claim, we're going to investigate, and the cost of missing a fraudulent claim, those are different for the company. So similarly, not understanding that you can't take these models or some numbers as most important outside of interpreting them correctly in your business context. I think there are generally mistakes of interpretation like that, and not having the right data and trying to generalize beyond the data to what the data can't tell you. So if I had to say it in a word, I'd say not understanding the limitations of the models.
Okay, thank you so much for that answer. Kelsey, the next question is around scholarships. Two people have asked, so I'm going to combine it and ask you, what kind of scholarships or financial support are available for international students, and how early should an international student start preparing for their funding applications?
Yeah, very good question. So for our international students, you all would be considered for our Terrapin Scholar Award. That award ranges between $2,500 to $15,000. You do not need to do a separate application to be considered for the scholarship award. Your application for the program that you're interested in is what we will use to evaluate your scholarship amount in the event that you're admitted. So you first have to gain admissions into the program, and then the admissions committee will review you for a scholarship amount. And then when you receive your admissions letter, it will list in your admissions letter what your scholarship amount will be. Scholarship is dispersed evenly amongst the semesters that it takes for you to complete the program. For international students, the standard duration of time in completing a program is 3 semesters, so that you're in compliance with your student F1 visa. But for additional funding and things of that nature, for if you're preparing it like for your I-20 form or things like that, I do recommend contacting our International Students and Scholar Services Department. And you can schedule virtual consultations with them as well. And you can also call into their office because each person's case is different. So I do recommend speaking with them directly so that you have a more concise answer based off of your personal financial background. And I can put their contact information as well as the link to their webpage to schedule a consultation in the chat for you all as well. I think does that answer the question? Is there a second part?
Yeah, that does answer the question. Thank you. I thought you were going to say something else, so I was just waiting.
Oh, no, no worries. No worries.
All right. Next question is for Dr. Prasad. Somebody wants to know that, Sunny wants to know that if you were designing a capstone project today for Smith students, what real-world data challenge would you want them to tackle?
Actually, I'll take this opportunity to say that many of our programs have capstone projects where students work with companies and companies bring data, bring a problem, and students work on that. And addition to that, my center and many other centers have student consulting projects. So obviously, people with your background, your kind of background, and the kind of education that you get are much in demand. So we have consulting projects that students can work on actual real world problems. So more directly to your question, so I think what are we looking for in the kinds of projects we admit for our students? We want to make sure that there is a genuine problem to be solved. People are not just passing off drudge work to students. I think that's not a I mean, there is a hierarchy of what are good or what are bad. I think the ultimate thing is if it's I think tough problems are good because they develop your skills better. So you would want, for instance, a complex data set which has a lot of pre-processing needed, that has a lot of predictive work needed. But I don't think it can come from any application. It can come from a manufacturing or a service or an IT, any kind of application. So that's what I'd say. It would have to be real world is one thing that I would look for. And the second thing is I would look for it to be a tough problem.
Okay, and there are some people who have this question that what kind of background do they need for the program for this data analytics? Will a commerce background student be able to enroll for this one?
Yeah. So I think, so unlike maybe in an engineering school or a computer science school, we're not looking for very heavy background. I think a quantitative orientation is more. Everything else you'll learn, and then there's sometimes programs and courses have pre-work, some videos to watch before you get here, that kind of thing that help. But no, we're not focused on that you only should apply if you did engineering. Not at all. I think wide array of backgrounds, as long as you are not intimidated by quantitative stuff. That's all we're asking for. Commerce would be fine. You would fit the business application side really well.
Okay, and the next question is for Kelsey. Just a second. Kelsey, what resources does Smiths offer to help students adjust to academic and cultural life in the university and the US?
Yeah, very good question. So we host a lot of different events here in admissions, and you can always check them out on our events webpage, and I'll put that link in the chat as well. But we have a lot of different cultural events that are led by our SMSA, which is our Smith Masters Student Association. That was the group that I had mentioned earlier. They pretty much connect with your academic advisors. That's where that organization sits, and they're student led. So there are different students of different backgrounds that are represented within the leadership of that group. And they do a very good job in making sure that students feel seen, they feel supported, because of course, when you're coming from different cultures and different backgrounds, your style of learning can be very different when you're coming to a university that's outside of where you're originally from. And for some students, that can be a little intimidating, which is understandable. And it can feel like a little bit of pressure. At Smith, the pace of learning, I mean, it is a master's program, so keep in mind, it is a little bit accelerated for some, but it's something that you do get accustomed to. And there's a lot of different support systems there for you. There are a lot of different student groups that surround your specific programs. Like there's a business analytics club, there's an information systems club, there's a supply chain management club. And then there's also support groups within your cohorts as well that students just kind of conjure up themselves, such as like tutoring sessions. And then there's also external clubs and organizations that plan around festivals around certain time of the year, such as like the Wally or things of that nature. That's something that's highlighted here at Smith as well. So there's a lot of different ways for students to feel included and part of the community. And I think that just getting involved, opening your mouth and speaking to your professors, and also getting acquainted with those second year students when you come in as a first year student is going to be very pivotal for you, just because they've already gone through the first phase of being a first time student, so making those connections when you have those courses with them, you'll be able to learn a lot more about how you can integrate yourselves within the Smith culture.
That was great. Before we wrap up, could each of you quickly share one quick tip for students here, something that they should keep in mind as they plan their journey towards grad school and beyond? I will start with Dr. Prasad.
Uh, oh, that's so one thing to keep in mind if you so one so that so once you've committed to the Smith School, I think I'll echo what Kelsey said, that you can already start getting in touch with second years here, and you can start getting in touch with other groups and organizations and find out as much as you can about the university, so that when you come here, everything goes very smoothly. The other thing is, in business school, we always emphasize the importance of making connections. One of the things that you're doing is, plugging into a network and building a network. So I would say, you should have the go out and meet people and get connected into all of the opportunities that exist for you on this campus, within classroom, but also outside classroom, to make the most of prepare you to make the most of your experience here.
Kelsey, what about you? One tip.
Yeah, one tip that I would say, and I always share this with even my current students that I still speak with, is when you're coming into any program, you're going to want to really have an open-minded perspective. There are a lot of students that are coming with various backgrounds, and you're going to learn a lot of different insights even though we're all, getting the same degree and we're all taking the same courses. There's students that are coming from journalism backgrounds. There's students that are coming from computer science backgrounds, criminal justice backgrounds, accounting backgrounds, whatever the case may be. But they all have different perspectives on how they're going to be integrating your lessons into their real world perspectives. That can really alter and change how you make informed business decisions within your own respective industry. A lot of students are pulling ideas from one another, and sharing of information is really, really key and important as well. And that's going to give you a better experience here at Smith as well, and just making sure that you're prepared in that sense. I know sometimes it's like, how do I prepare to have an open mind? Just expect the unexpected. I think that's really important, especially when you're learning a lot of different concepts, and being okay with being uncomfortable. That's the business world. There's different challenges that come about within our economies every day. And so being okay with being uncomfortable and having open-minded perspectives is my huge tip for students.
All right, that was really great, and thank you all for joining and for your active participation. We hope you're walking away with valuable insights into data-driven decision making, applications of predictive analytics, and the opportunities available at the University of Maryland's Robert H. Smith School of Business. A huge thank you to Dr. Prasad and Kelsey for sharing their expertise and time with us today. We look forward to staying connected and supporting you on your journey to studying abroad. Thank you once again, and we wish you all the very best for your future. Thank you, Dr. Prasad. Thank you, Kelsey. Thank you.
Thank you, Chetna. Thanks, Kelsey. Bye bye.
Bye.
Thank you all. This was awesome. Have a good day.
Bye. Bye.